In this lecture, we're going to explore file I/O operations in Python. File I/O, or input-output, is essential when working with data in a more permanent way, such as saving data to a file or reading from one. We'll walk through the basics of working with files, discuss different file modes, learn how to manage file paths, understand context managers, and finally we'll touch on handling file-related exceptions. By the end of this lecture, you'll have a solid understanding of how to handle files in Python. Let's start with basic file operations. When working with files, the first thing we need to do is open a file. Python provides a built-in open function to accomplish this. We can use open to create a file object, which allows us to perform various operations like reading from or writing to the file. Let's create a new folder called File Operations for our practices. Make sure it is inside the Basics folder of our PyProject directory. Now we create a new Python file and name it filewrite.py. Inside this file, let's write some code to open a file. Here, we've opened a file named example.txt in write mode. This means that if the file does not exist, Python will create it. If it does exist, the content will be overwritten. Next, let's write something to the file. This line writes the string "Hello World" to the file. Notice that we're using the write method, which is used to write data to the file. After performing operations with a file, it's important to close it to free up system resources. We can do this with the close method. Let's run this code to see what happens. Once we execute this script, a file named example.txt will be created in the root directory of your project. And if we open it, we should see the text, "Hello World." Now let's move on to file modes. Python allows us to open files in different modes depending on what we want to do with the file. The most common modes you'll encounter when working with files in Python include R, which is the default read mode used for opening a file for reading, W, which opens a file for writing and will overwrite the file if it already exists, A, which is used to open a file in append mode, allowing you to add new data to the end without overwriting the existing content, and B, which can be combined with other modes to handle binary files, making it useful for reading or writing non-text files such as images or executable files. Let's create a new file called fileappend.py to demonstrate another mode, like the append mode. In this example, we've reopened example.txt in append mode and added a new line to the file. Now when we run the script, you'll see that the new text is added to the existing content instead of overwriting it. After discussing how to write to and append files, let's now explore how we can read the contents of a file using the read mode. Reading from a file is just as important as writing to it, and Python makes it easy to access and process the data stored in files. Let's see how we can do this. I'll generate a new example called fileread.py. In this example, we open the example.txt file in read mode by passing R to the open function. We then use a for loop to iterate over each line in the file. The strip method is used to remove any extra white space or new line characters at the end of each line before printing it to the console. This line-by-line approach is beneficial when you want to process or display the contents of a file incrementally. For instance, if your file contains a list of items, you can handle each item individually. And never forget to close the file. When you run this code, you'll see each line from example.txt printed out on the console, exactly as it appears in the file, but without any extra whitespace at the end. This method is a great way to handle file reading in a more controlled and memory-efficient manner, especially for large text files. Next, let's talk about file path management. Sometimes we might want to work with a file that is in a specific directory. Python's OS module is handy for handling file paths. For example, let's create a file in a different directory. I'll do it in a new Python file called fileoutput.py. Firstly, we need to import the OS module, which provides a way to interact with the operating system. This module will help us work with file paths and directories, ensuring our file is created in the desired location. Now we create a new directory and file path. Here we're using os.makeDirs to create a new directory called output, and then joining the directory name with our file name to create a full file path. This ensures our file is created in the output directory. Finally, we use the path we created. As we've learned, we open the file, write to it, and then close it. Let's run this script and check the output directory for the new example.txt file. It should contain the text we specified. Moving on, context managers provide a more efficient way to handle files. Using a with statement in Python is a preferred method to work with files because it automatically handles closing the file, even if an error occurs during file operations. Let's rewrite our code using a context manager. I'll set up a new file called filewith.py for that. In this example, we don't need to explicitly close the file. Python takes care of it as soon as the block inside the with statement is done executing. Next, let's talk about handling file exceptions. While working with files, things can go wrong, such as trying to read a file that doesn't exist. Python allows us to handle these situations gracefully using try and except blocks. Here's an example, which I type in a file called fileerror.py. In this case, if the file doesn't exist, Python will raise a file not found error, and our except block will catch it and print a friendly message. Notice that in addition to our custom message, we also printed the default error message generated by Python. This gives us detailed technical information about what went wrong, which can be helpful for debugging. One important thing to keep in mind is where our files are saved. By default, when we create a file without specifying a path, it is saved in the root directory of our project. But what if we want the file to be created in the same folder where our script is located? This can be particularly useful for keeping related files organized. Here's how we can do it. I'll generate a file called filescriptdirectory.py. To achieve this, we need to determine the path to the script's directory, and then use it to create the file in that specific location. Python provides tools to help us find the directory where the script is being executed. One way to do this is by using the OS module, which I import. In order to get the directory path of the currently running script, we use this line. The file variable contains the path to the script, and os.path.appspath converts it to an absolute path. We then use os.path.directoryname to extract just the directory portion. Next, we create the full file path by joining the script's directory with our desired file name using os.path.join. This ensures that our file will be created in the same folder as the script. Finally, we open the file in write mode using the full path and write some text to it. When you run this script, the file will be saved in the same directory as your Python script, not in the root directory of the project. Let's run this code to see it in action. After executing the script, you should find example.txt in the same folder as your script, and it will contain the text, "This file is created in the scripts folder." This approach is particularly helpful when you want to keep all files related to a script in one place, making your project more organized and easier to manage. Now let's make a quick summary of what we've covered. We learned how to open, write to, and close files. We explored different modes for opening files like read, write, and append. We discussed how to manage file paths using the OS module. We saw how to use context managers for more efficient file handling. We learned how to handle errors gracefully when working with files. That's it for File I/O operations. You now have the tools to work with files effectively in Python, from basic file handling to managing paths and handling errors. Keep practicing these concepts and you'll be well on your way to mastering file operations in Python.